to do too many things today. I'll just stay with the red black, and whenever you are done, I'll take questions if we finish early or something like that. Okay. So if you remember, if you look at your note that we did in our last class in person, we had this case 1, okay, where we are considering the color of the node that we are adding is the color of the parent of the node. So I'll just write it down just so that you have that visual in front of you that we were doing. Okay. So case 1, we had, oops, I don't want that, red. Case 1, we had if color of P okay, so this is the case that we're looking at. So color of parent of the node that we're adding is black. That was our case 1, and we are basically doing nothing in this case. Okay, that's our case 1. All right, so in case 2, the color red, we're saying the color of G, that is the grandparent, is black. Okay, I'm so sorry about the background noise. My son just woke up from his nap and, you know, demanding a lot of things. Okay. Oops. Sibling, that we were saying the sibling of the parent, which is the uncle node to the newly, could be black or red. So this is what we were doing, and we started with case 2A, where there were symmetric cases and there were exact cases as well. Today, I'll start with the S colored red, okay? Because I believe that is easier to deal with, and then I will go to the case where the color of S is black. So this is something that we didn't cover in last class, so this is where I'm starting with, okay? So if X is the one that we have added, you know, as the new node, then the color of uncle of X, that means that we are indicating as S, okay, that is red. So we are considering now this one. The color of S is equal to red. Okay, so if that is the case, what we are doing, okay? So if this is the case, we will simply recolor with easier, okay? Basically, no rotation required in here. We will perform recoloring, okay? And how does that happen? Where to start and what to color what, like which node I should color what. So that's what we will look at, okay? So before we start giving the example, just think that the new node that we are starting, adding is always red, and color of its parent is red, and the color of its grandparent is black, and the color of its uncle, that means the sibling of its parent, is red. This is the case that we are going to look at now, okay? So I will erase this and start in a new blank page, and I will keep this on the side so that we have that on top of our head, okay? So when just, I don't know, can I create a new page in here? This is the first time I'm using the pen. Okay. Oh, okay, we can slide down, so that works. That's a word. Okay, cool. Just so that, okay, no, that's not what I want. Okay, if that helps, just give me 1 second. I think that would be more helpful. I will type it down here. Okay, parent. Okay. So this is what we are looking at. Okay, it's good to have on the site so that we can remember. Do you guys want me to share this that I'm writing? If yes, I can do that for sure. I'll do that. Don't worry. Okay, so where I'm writing, it's a doc. I should be able to share that, guys. Okay. Let's begin. Let's start with a very simple example. Okay. All right. So here is, let's say I am inserting 35. You know that, well, when I inserted 35 it is always red, but it is the root of the tree, so we recolor it. If it's the root of the entire tree, we recolor it to black. Okay, so basically that is also another scenario that we might consider. Not actually we have to when we're programming. So if you know that we just inserted is the root of the tree, we must recolor it to black. Okay, so and you can see that on the visualization tool that I have shared with you in Moodle. So, okay. So let's start with that. So now, okay. When we insert, let's say 15 in here. So when we insert a new node, okay, that is red. And every time a new insertion is happening, we are looking into two things, black property and the red property, if you remember from the last class. So red property says we cannot have red nodes. And the black property is, do we have the black height as the definition? That is the same number of nodes, like not starting from the root to its null reference. Okay, so if we consider that we have a null reference in here, which is black. Okay, so yeah, so far so good. Okay, so in this tree we have started, like added a new node 15, but it's still keeping the red property and the black property the way it should be to keep the tree balanced. So we are not in this at this point, right? So no no rotations, nothing. So I will get now. Let's say I will insert a node 50. Okay. Actually, let's just give me 1 second. This was D. And I will add a new node 50, let's say, okay. And that's going to be red. Till now, I think you can tell that tree is balanced the way it should be with its red property and property. Okay. All right. Now let's insert 11. Okay. And again, whenever we are inserting any new node that is red, so here we go. Okay, so now is the problem, because you can clearly see that the problem is broken in here. So it has red node that we can have. And if we look at the case that we are considering, that newly added node X is red, okay? Parent of X is red. So if this is X, this is P, this is S, we can tell which one is, okay, red. And the grandparent is black, we can tell absolutely. Okay, and the uncle of X and the city is red. So all of them are satisfied now to the case that we're looking at, okay? Now it's time that we have to form recoloring, okay? So we are recoloring at this time, no rotations, nothing. How do the recoloring starts? Okay, and here. So we have started, inserted the new node 11, which is X. Go to the level where G is. Okay, I will repeat. I inserted the new node 11, which we have denoted as X, and go to the level of G. Okay, so you are going 2 levels up from X. You start recoloring from, okay. So I go to G of X and I will start recoloring from here. Whatever color is there, we will alternate them. For example, if G is black, I convert it to red if of P will lead to the entire subtree that we're working. Okay, so we will convert this both children of G. Okay. Okay, I'm glad that you mentioned. Okay, I am receiving some like some pop-ups that internet connection is going out for a while. Okay, just give me 1 second. Okay, I'll try to reconnect. Okay, by this time, before I leave, I'm not leaving actually. I'll try to reconnect. I'll just change my network. That's the confusion. Okay. Put your attendance. Okay, go to your Moodle. Okay, I see everyone is having some issue. Okay, I will try to reconnect to my Wi-Fi and see if that is improving. By that time, please go to Moodle and attendance in. Okay, I have made it self-attendance, your own attendance. Go to Moodle and I will try to reconnect. Okay? Okay. I changed my Wi-Fi connection. Hopefully it will be better. Okay. Let me know if you're still having trouble, okay? You can just speak, like unmuting your microphone. That's fine. You do not have to type. But if you prefer typing, that's not a problem either. So whichever works. Okay, so let's begin where I was. Okay, so here, so what we're doing, so we will go to the level of G and we will start recoloring level, okay? So, and it is for that subtree that we're, okay? This is kind of the situation that this is the whole tree that we have got now. Soon the situation will change. I'll give you an example for that too. So from X, I'm going to G and I will start recoloring. And how will that look like? So I will draw it in here. I will convert, so that my G was black, so I will convert it to red. My nodes in the level of P.
Hey, excuse
yes.
me, but
yes, is that Ali?
it doesn't show the board or the
Oh,
light.
yes, right. Wait, just give me 1 second. What
Sure.
happened? Boy. Okay, 1 minute. I'm trying to fix it. God. Okay. I think that should be visible now.
It's working out, yeah.
Okay, cool, thanks. Oh, cool. Now, so I've started recoloring already from G. So G was black initially. Now I have converted to red, and I'm doing the same thing for the rest of the nodes in my tree. So I made, I'll keep the notations. And I will convert this to, okay, just give me 1 second. I will, okay, this version of Zoom does not allow me to record it in the cloud. However, I will be sharing the notes that I'm using, and I will share some more supportive resources that I'm sure will be helpful. Okay. Okay. Here. And then, okay, see what I have done. I'm not done yet though, okay? So I have, oh, okay, thanks, David, if you're recording. Okay, so I have started from G, okay, and I have changed the color of 35 to red, and then I moved on to the next level, and I converted the colors, node to black, and I will not do anything with the X though, okay, it is the color is, which is red. So what I'm doing, I'm going 2 levels up from the X, and I convert the colors, the existing color of the nodes to the alternative color. And that's what we will do, okay? Now, see the problem with this tree, except for the red property or the black property. You can just type it in or just take like 30 seconds to see and figure out if there is anything wrong with this tree according to its properties. Yes, excellent. I see, like, yeah, yes, you're saying like root cannot be red. Yes, awesome. Okay, thanks guys. Okay, so currently 35 is the root of the entire tree. Okay, the root, not the root of the subtree. So if that is the case, I will write it down in here. If G is the actual root of the tree, then we perform one more recoloring. That is, we convert the root to black, but this applies to only if the G is the root, the actual root of the tree, not the root of the subtree. Okay, so okay, that's what. Okay, so I will now do that and draw the next final. 35, then 50 and 50. And so if this is the case, this is how my final tree looks like. Can you check if it is satisfying all the, I shouldn't say conditions, does it hold all the properties of the red-black tree should have? For example, the black property, which is the black height. So, oops, sorry. Okay, null mode. Okay, Matthew, when we are recoloring, we will do on the level of that subtree that we're working, okay? So please be careful, I'm saying level of the subtree. So if we had another kind of branch of the other side, we had greater, like other branches, if we have a bigger tree, we won't apply to the actual level of the entire tree, the level of that subtree that we are working, okay? So we recolored the G to red from black. Then we came back, I'll use a little bit of annotation in here. Okay, here. So here. So when we performed the recoloring of G, we came back to the next level of P and we changed the color of both the children of G to black. Okay, that's how we perform recoloring. And that is how the 15 and 50 both became black. And the X remain as it is. So those are the things that we have to remember. Okay, one more time. Okay, so start from X, go 2 levels up to G and start recoloring. If G is black, change it to red. Go down and convert both the children of G to black. Okay, and then the X is as it is. We are not recoloring X. And then when we are done with that, if we see it is the root itself of the tree, the root, then we perform another recoloring. We convert the root of the tree to black. And now you can count the black height, okay, and see if that is working, and the red property. So looks good, right? We're not done. We will work more on this tree so that we can see how it's going. Okay, now let's do NAP. Okay, I will insert 27 to this tree. Okay, we will insert this 27. You know that whenever we insert a new node that is red, and if you try to figure out where the 27 will go, you should be able to tell it is going to be the right child of 15. 1, 5. Okay. So if we want to do that, I will just use this eraser. Okay, that's not what I want. And this is 27. Okay. Anything violating the red property or the black property? I guess it is good. So we do not need to do anything at this point. Now, if we decide to insert 5, if we do that, you can tell that this is the location. I think we're at the end of the page, so I have to go. New node is always red, and inserted 5, and the red property is not broken. We cannot have red node in the tree. So this is the same case that we are working with. Okay, if we go a little higher, here I say newly added node is X. Yes, it is X, which is red. Parent of X is red. Yes. The grandparent of X is black. Yes, which is G. And the uncle of X, the symbol P that we're denoting as S, is red. Let's do notation. So this is the X, P, S, G. Okay. We can do the same strategy of recoloring for this tree. If you are willing to do it by yourself, you can do that. And if you'd like to share with us, you can just write down the colors of nodes in your chat box, or you can just say it if you have that. But concentrate on this particular subtree. Okay, because those are the notations that we're working with. Okay, try. Meanwhile, I will just try to get into the new page. Okay, sorry. Oops. Okay. Okay, excellent. Getting feedback. 15 is gonna be red. 27 are black, and 5 is red. Excellent. Excellent, Matthew, Ricardo. Yes, John Burrow. He's black.
Quick question.
Yes.
So if G isn't the root and it's red, then it's fine. We don't have to.
It's fine. Absolutely. That's the next thing that I'm going to talk about, actually. And you got that. Awesome. Okay, so let me draw it. I think many of you already got it. So let me draw it in here. I will start recoloring the way I have done before. So 35 is remaining as it is. That is not the subtree that we are working with, so we don't care. Okay, now the recoloring starts, and my 15, which is the G, becomes red. Then the next two nodes, P and S, will be black. And the X is remaining. Oops, not the right color. No, I was right. Okay. Okay, that is X. So we have performed the recoloring, and look into this subtree here where we have performed. And in this example, G is not the root of the tree, right? It's not the root of the entire tree. Although we will denote G as the root of this subtree, but not the root of the tree. If that is the case, then we should be fine, okay? So we do not have to recolor G anymore, okay? So let's double check if everything, so we can clearly see that the red property is fine, but let's figure out that the black property is still going well. Okay, like it is. Okay, any questions? Okay, so now the thing is, this is the scenario that we will see more often when we are inserting new nodes. I'm really sorry about that. Okay. So when we're inserting new node, this is the scenario that we will see more often. So I would encourage you to go to that visualization, okay, just in case. Okay, go in there and check by yourself like how it looks like. So when we're inserting new, this is the scenario that you will see more often, okay? But then when does the case that we were working with in our last class occur? Well, in insertion, that may happen to especially case 2A, we will see that. But case 2B was kind of, not 2B, sorry, 2A1 and 2A2 was not something that we will receive frequently due to addition of new nodes. It happens more like when there are deletion in the tree. Okay. All right. Okay. Greg, I'm glad that you asked. Actually, I haven't numbered since we said the others. Okay, just give me one second. Let me number this. Okay. Let's say this is case. Okay, let me see what are the other numbers that I have denoted. Okay, case 2A. Okay, let's say this is case 2B. Okay, so case 2B. And just in case if you're wondering, oh, why not shooting?
So everything we've done so far is case 2B?
Yes, today's class, it's 2B.
Okay.
I will now go back to case 2A because you already know that. And but the problem is, for some reason, it is not. Okay, I will reshare. Just give me 1 second. Boy. Okay, David, I hear you very like, yeah, that's better. Yes. Yes, absolutely, I can do that. Just give me 1 minute. 1 minute. I'm just trying to reconnect. I don't know what's going on with this one. Okay, we're using Wi-Fi. boy. From next class, I will be using cable. I don't know what's, okay, so everything looks good to me, but. Why it's not working? Okay, it's trying to reconnect. Just give me 1 second. I'm trying. Yeah, I tried to connect it with the cable, but I don't know why it's not working. I have to do some more demo. Okay, so the property, okay, the thing is, okay, so start counting your number of nodes starting from the root to the furthest leaf, okay? So look at in here. So from root, start counting the number of black nodes to the to the null reference. Okay, I have missed drawing 2 null references in here, which I'm drawing now. Okay, so let's start counting that. So 1, 5, 2, 3. Okay, that's what we are getting in this path. Then let's see 1. Oh, I'm sorry. Not that one. Okay. 1, 2, 3. Okay. So again, 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. Then 1, 2, 3. 1, 2, 3. So starting from the root node to the null reference in any path you take in the tree, that is your black height, and it should be the same number for any path that you're taking, starting from root to the furthest null reference. Okay. Does that make sense? Or still any confusion? Please ask questions. Okay, awesome.
I have a question.
Sure.
So you just skip the red nodes, right? When you count in the black height?
Exactly. Yeah, absolutely. Because we are counting how many black nodes are there in that path. Okay. Yeah. Okay, any other question? Okay, I see.
Yeah, I have one.
Yes.
So could we have used this whole recoloring for like any red and black tree?
Do you like, what do you mean by total recoloring? Is it like the recoloring the entire tree?
Well, okay, so in order to like balance it, we're using recoloring, yeah?
Yes.
So then, okay, so for example, like the trees that we got for the quiz last week,
Yeah.
technically speaking, could we have used recoloring?
Actually, okay, let me see if I have the tree in front of me that I gave you, which was a very good one. Because yeah, I found that. Okay. Yes, you are. No, wait, hold on. The tree I gave you, that like the one that I changed afterwards. Just give me 1 second. 1, 2, 1, 2, 1, 2, 1, 2. For that one, we will recolor after rotation. Okay. So if you are recoloring after rotation, that will work because it is the case 2A, okay, that I will talk about now. Okay, we already have talked about in class before, but now you can relate more, okay? So in that case, you had to first perform the rotation and then the recoloring. But in that case, I think you were asked, I think Emmanuel, yes, you were asking this question, if I'm not mistaken, I could be wrong, that, well, if it's the root of the tree, then what do we do when after the recoloring? Yes, so absolutely, this is the rule of thumb. If you see after the recoloring, or in any case that you are done with everything and the root of the tree, of the whole tree is red, you are definitely recoloring it to black. Okay, so that is kind of the rule of thumb that you're doing.
Okay.
Yeah. Okay, so let's look at this example, like the next one that I will be working with. Okay, I can share the clips of the notes that I provided last class. That will be helpful. Okay, to start over, I do not have to rewrite this whole thing again. Okay, I'll share a different screen now because this is in here. Okay. Okay, I'll do a new share in here. Okay. can see that. This is, don't look at the tree. Look at the case that we talked about. This is something that we have done last class. Okay, I will share these cases with you guys too. Okay, so I'll prepare a note, like a class lecture note or something today, and I'll upload that. So I will share these two as well, like now. Okay. Why it keeps saying that my internet connection is unstable? Okay. All right, cool. So when case 2A, we're talking about the color S is black. The rest is remaining the same, okay? So here we have a symmetric case, okay, where there will be zig-zig situation, which was the one that you have seen in your quiz, which I basically made kind of a practice problem because the tree was, I haven't, like probably you can do it now because you know the rules of recoloring starting from the root. So you'll be able to do that, but at that point you didn't know about those rules. So yeah, so case 2-1 is symmetric. So if it's zig-zig, then we will do single rotations and perform recoloring. You should all have these cases, okay? So written, because this is something that we did in our last class. And this is the zigzag, which is the case 2A2. So which is kind of the triangle case, okay? So here we are doing this perform double rotation, okay? And then recoloring, okay? So this is something that we will look at into an example right now, okay? But to go to this case, to reach out to this case, we have to go through the case that we just looked at, which is the case 2B, okay? So let me go back to my drawing. Okay, so here it is. Let's just figure it out. Just start with this tree. Okay. So we are now looking at case, both actually, case 2A and 2B. One will come after another. Okay, so how does that work? Let me draw this first. So my tree. So I'm drawing this tree. Okay. Before we insert any node in here, just check if the black property and the red property is fine with this one. I believe it is. So if we start counting the black property from 8 towards this direction, 8, 5, and the rest. So yeah, just take like a moment and check if the tree looks good.
Hey, I got a question.
Yes.
So the height for the black like node, I think that is it 2?
For this one?
Yeah, it's like we go from 8 to 19, that's 1, and then from 19 to the null reference, that's 2, right?
Okay, so here is the thing. I'm glad that you asked. I was thinking that I will talk about it at the end. Do remember me saying in the past, like sometimes, okay, the height of a tree is considered with the number of nodes, but the definition that we started with in our class, the height of the tree is considered as the number of edges. Okay, so here it's no different. Okay, so it is kind of like some of the books have mentioned the black height with the number of nodes that you're having, and some of the books they have mentioned as the number of edges. So if you are working with the number of edges, do with the entire tree, okay? Every time, just stick with that. If you are working with number of nodes, stay with number of nodes with the entire tree, okay? So none of them are actually wrong, okay? So you can work with either. So if you want to stay with the number of edges, fine, but then apply that to your entire tree. If you are staying with the number of nodes, stick with that, okay? So I was probably giving the reference with number of nodes in here because it's easier to look at, like how many black nodes you have. But then again, I will say if you are staying with number of edges, it is simply -1 to the number of nodes that you are having. So whichever you prefer. And just so that you know, that does not impact the time complexities of operations much because it's just -1. Okay, so no, it got disconnected. Okay, what's that? Yeah, I'm looking at it. No, it keeps just going out. And I'm trying with the cable and this is bad. I'll try to work with the cable for next class. Okay. All right, so yeah, so for this tree, I think, yeah, so it's balanced the way the red-black tree should be balanced. Okay. Okay, now if I say I will insert 10, okay, so I will insert 10 to it. Okay, so if I do that, okay, let's see, or no, no, not 10, because, oh no, that's fine. Okay, insert 10. Okay. Let's start with that. So you can tell it's going to be the right child of 9. And newly added node, that is always red node. Hence, it will be something like that. So now you know how to work with that. First of all, it is the case 2b, because you see that The parent of 10 is red, and the sibling of P is I mean, do you know that? This is X, P, S, G. Okay, so you can tell this is case 2B that we have learned like 5 minutes ago.
Can I ask you a
So,
question? Can you hear me?
yes, Greg.
Okay, so what I had in the notes is like we had a 2A, a 2A1 symmetric,
Yeah,
2 zigzag.
right.
And when we left off class, we were working on a tree that wasn't quite, we didn't finish like a.
Right. Yes, you're right.
So where are we at right now with 2A and 2B? Is this like a combination of both? Maybe I'm.
Okay, I see what you're saying. Okay, the thing is,
same.
as I was saying, yeah, so the thing is, I was saying like, it is hard to create this scenario of 2A1 and 2A2 just by insertion, a new value, okay? So the case 2A1 and 2A2 appears maybe from some sort of other kind of modification in the tree, okay? So it could be deletion, or it could be something like the case that I am showing you right now. So I have started with inserting the node 10 in here, and we saw that this is actually a case 2B that we have talked about in today's class, but eventually I'll show you how it is taking you towards the case 2A. So I'm saying which one it's going to be, 2A1 or 2A2, that we will figure out when we are at that point.
Okay, so we're kind of working backwards, so to speak.
Exactly. I thought that I will tell you about 2B first because that is easier, and through this I can take you towards the case 2A, like 2A1 and 2A2.
Hey, I'm sorry. So my connection got cut off like 2 minutes ago when you just inserted 10, and I didn't hear after what you said. So
Okay, we didn't do much after that. We haven't done anything yet.
okay.
You haven't missed anything. And again, you will see this document. I will slightly modify it and then upload it, and then just ask me questions next class as well, because we are at the very end of the class and probably I won't be able to finish it today. So let's just stay with that, this one, and then we will continue next class. Okay, just a quick question. Is it convenient to view the screen the way it is, or do you think the whiteboard might be more helpful if it's sitting behind me and you can see that? Cool.
It is better. Yeah.
Okay.
Yeah.
Okay, excellent.
Yeah, I like this. Yeah.
Do you feel comfortable if I turn my video on, or this is fine?
That's good.
I mean, if you want, it's not much of a
It don't
difference.
matter.
The only thing I think is tricky is you're working in colors, and when we do it on the test, we're going to have to work in some kind of other notation. So, for example, I'd almost rather do the double circle around the reds anyway, just to
Prefer that? Do
follow
you prefer
through.
double circles? Okay.
I would just bring a red pen though.
Well, we could do that. Yeah.
Okay, guys. Okay, so I will post this. Okay, we're kind of at the end of the class. So what I'll do, I'll post this document, okay, and I will post some extra handouts, okay, that I have, like we have gone to online, and it will be very helpful for you guys to have some materials on your end. So I will definitely upload this and some other materials and some handouts that I have drawn myself with double circles, okay? So if those are like this drawing of the same tree that I'm drawing it in here. So just in case if that's more convenient to look at, just look at that. And maybe the next trees I'm drawing, I will use double circle if that is more convenient. Okay.
Another question. Is still our test next week?
I think we will, but not. Okay, let's talk about next class. Okay, I'll confirm next class because I have to figure out some stuff before I do that. So next class, I'll confirm the date. For now, consider whatever is mentioned in class next Tuesday. Did I? No, sorry, next Thursday, right?
Okay.
Yeah, next Thursday. Let's stick with that for now. Okay, thanks, Max. Okay, let's stick with that for now, and next class I'll confirm. Okay.
Hey, so our next class, are we doing more examples of this?
Yes.
Okay.
Yes. I will. I don't know. Like I will prepare some examples for you guys so that you can work on them. And the way I took some maybe feedback via chat, or if you want to. I don't know. Can you guys share your screens too?
Yes. I
Okay,
believe so.
you are willing to, that you will just like hold your notebook in front of the camera. That will be fine. Okay, so the thing is, okay, this is the tree of God. You can, I will post this. Okay, let me post this after next class. Okay, just if you are just taking the screenshot of this tree, just this one, the one that is on your screen now, for your practice, but I'll solve it in class, that how to do that. So this is case 2B that we have talked about. Solve that way, the way we have done, and then we'll take it start from here where I am leaving it on. Okay. So let's do that in next class. And that is the end of this chapter. Basically, there is nothing more left. We'll talk about the test next class, and from next class I will be mostly using PowerPoint slides. Okay, so that could be helpful, and we can always do some practice drawing and stuff the way we're doing now. Okay, and please do not forget to record your attendance in Moodle. Please go to Moodle and record your own attendance. It will be active. I think it will be closed by next 3 minutes. Okay, so try doing that. Okay, so I will see you on Thursday. Meanwhile, if you have any suggestion like that you think it'll be helpful when we are doing online classes, feel free to email me, and yeah, we'll do that. Okay. Yeah, but I cannot do that because this is the free version and it doesn't allow that. Yeah, so we are working towards the pro version. So maybe soon. If not, just record in Moodle. Okay, that'll be fine.
A question.
Yes.
Would it be possible maybe just to like scan a couple of your notes to the Moodle as well, like what you were going over, just to make sure I have what I'm supposed to have?
Yeah, absolutely. That's what I am planning to do. The one that I have done today, for example, this